Chapter 3, Decisions, Part 5. Hand tracing is an invaluable tool for being able to understand whether or not your program works correctly. So how to do this is you create a table of key variables. You use a pencil and paper to track the values of the variables. And it works with pseudocode or with code. You track the location with a marker such as a paperclip or your finger, and you use examples of input that will let you know what your correct outcome should be, and it will allow you should test every branch of your code. So here's an example of hand tracing. We want to trace through and see what will happen to the variables tax 1, tax 2, income, and meritable status. You notice at lines 15 and 16 that we initialize tax 1 and tax 2 both to 0. So we've written that in our table when we're hand tracing. Then we go through and we assume some values that the user would enter. So we assume that they would enter an income of 80,000, and we assume that they would enter a marital status of M. Because the marital status is not equal to S, we skip to line 41 in the code. And then we test if income, which is 80,000, is less than or equal to the rate 1 married limit. And the rate 1 married limit is 64,000. So it's not less than 64,000. So we go on to line 49, where we set tax 1 equal to rate 1 times rate 1 married limit, which is 6,400. And we set tax 2 equal to rate 2 times income minus rate 1 married limit, which will calculate to be 4,000. When you're actually doing this by hand instead of just watching the video, if you can't do the math by hand, feel free to use a calculator. You should also use a calculator to validate that the results you're getting are the results that you expect. Then at line 54, we calculate the total tax, in which we add tax 1 plus tax 2 and come up with 10,400, and that would be output. Does that match our expectations? Yes, I think it does. So we would go on and test another set of values. A common error is to have a dangling else. Take a look at this code. Double shipping charge equals 5.00. If country.equals USA, if state.equals Hawaii, HI, then our shipping charge is $10. Else, our shipping charge is $20. Well, wait a second. That else should go with the country equals USA because it's a foreign shipping charge. But in fact, that else, because the else matches with the nearest if, the closest if, it's saying if the state is any other state besides Hawaii, then it's going to be $20. So this is an example of a logic error. Because it's syntactically correct, it will compile, but it doesn't give us the output we expect. How could you fix this problem? You could fix this problem by putting a brace following the first if statement and a corresponding close brace right before the else. That would group the if state.equals HI shipping charge equals 10. That would group that, so that would happen as a result of the first if, and then the else would pair with the first if. Let's take a look at flowcharts. We've used a few basic flowcharts, and a flowchart it's really good for showing structures of decisions and tasks to solve a problem. There are basic flowchart elements. The rectangle is used for processing or a simple task. The parallelogram is used for input or output, and the diamond is used for a condition, such as an if statement. When we have a diamond, we always need to label the flow lines exiting that diamond and indicate which path is true and which path is false. We should never point an arrow inside another branch, so the flow lines shouldn't cross, and they shouldn't point into they shouldn't go into some other logical pathway. Here are some examples. With two outcomes, we have a condition with a true path and a false path. With multiple outcomes, we have choice 1 and our true path. Our false path will lead us to choice 2. If that's true, we go on our choice 2 branch. Our false path leads us to choice 3, and so on. Here's an example of that shipping cost flowchart. So we want to ask if the shipping costs are $5 inside the United States, except that Hawaii and Alaska are $10. International shipping costs are also $10. So we have 3 branches. Is it inside the US? Then set the shipping charge to $10. If it's inside the US, we follow the true path where we go and look and say, is it inside the continental United States? If it's inside the continental United States, we set the shipping charge to $5. If it's not inside the continental United States, we set the shipping charge equal to $10, but that path is not shown on this flowchart. And finally, if it's not inside the US, we set the shipping charge to $10. Notice that we can't go back up with that flow line from continental US being false. We can't go back up and into the shipping cost equals $10 for that flow line for inside the US being false. That would be, logically, we can't do it in Java, so it would not be correct to show that representation in our flowchart. Here's a better example. Notice how shipping cost equals $10 is a result of the continental US flow line being false. And we have 2 places where we set shipping cost equal to $10.